Okay, so this lesson we're going to talk about perfect squares, perfect cubes, and we're going to start looking at roots. So square roots and cube roots and just how roots work in general. So I'm going to start off with sort of a geometric way of looking at perfect squares and perfect cubes, and it helps you understand where the names came from. So a perfect square is any number that shows the area of a square. The square root is the side length. So 16 is a perfect square because you can make a square with 16 squares. Now, if I look at a square, it's 4 by 4. This is a square root symbol, which I'll explain a little bit more in a second. The square root of 16 is 4 because this side's 4, and then I can also write a 4 over here. I don't know if I cut it off or if that just wasn't, no, it wasn't there. So this side's 4, that side's 4, and so we'd say the square root of 16 is 4. Okay, so I have some smaller squares here. How many squares do we have here? Total? 9. So I'm just going to write 9 in the middle, kind of like they had 16 over here. So 9 is a perfect square number. And then if we look at the side length, we have 3 and 3. So we could say that the square root of 9 is 3. And that happens because 3 times 3 is 9. So this is an inverse of squaring numbers. So this 9 up here, I'm just going to write is 3 squared. The square root is the opposite, going backwards. Well, what was squared to get 9? It was 3. Okay, so in this next one, I'm not going to make you count them. There's 4. So this side is 2, and this side is 2. So raise your hand and tell me what the number sentence would be that I could write for this using a square root. Or do you need me to explain one more? So I want a sentence like this one. Anybody want to try? I can just start picking on people. Oh, you're trying to draw. You don't have to do the brackets perfectly. Just write 2 on the sides. It's fine. Okay, so over here, I had the square root of 9 is 3. Over here, what number sentence could I write that's like this that explains the relationship between 4 and 2? Jaden, he's got his hand up.
4
So the square root of 4 equals 2. Good. Now this last one is kind of special. It's just 1. And it's 1 by 1. 1 squared is 1. And so this one, the square root of 1 is 1. So that's sort of a special case where the square root of a number is the same number. The only other one I'm going to put over here to the side, the square root of 0 is also 0 because 0 times 0 is 0. 0 and 1 are the only special ones that work that way. Okay, so I'm going to explain that a little bit more in a second. This is just sort of an intro, and it's got these pictures, which I thought would kind of get our brains into an understanding. So perfect square numbers are numbers that would have been squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Can anybody give me another perfect square number? Something that's been squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. What would be another perfect square number? Johnny's got his hand up.
18.
So what squared gives you 18?
9.
So 9 times 2 is 18, but 9 squared is not 18. TJ?
5 squared.
5 squared, and what is 5 squared?
25.
25. So what is 9 squared? Going back to what we had. What's 9 times 9? 81. So those are some other perfect square numbers. So what I want to do, if you've got some space in the margin or just somewhere up here with the perfect squares, I'm just going to make a list really quick. So 1 is a perfect square number because 1 squared is 1. And then 2 times 2 is 4, so we had 4. 3 times 3 is 9. And we had 4 times 4 is 16. 5 times 5 is 25. What's 6 times 6?
36.
36. 7 times 7? 8 times 8? 9 times 9, we just talked about, is 81. And 10 times 10 is 100. And then we can go further. I'll do some more with that later. We're actually going to memorize some perfect squares and then their square roots. And it's sort of like stepping it up from multiplication facts and things like that. Square roots are things we will also need to know and identify those perfect squares to be successful next year in high school. Okay, so let's go down and look at perfect cubes for a second. Okay, so a perfect cube is any number that shows the volume of a cube. The cube root is the side length. So this is giving you sort of a geometric definition. And then I'll do more of a number sense definition on the other page. So here's a cube. You have to use your imagination a little bit because you can see 4 blocks in the front and then there would be 4 blocks in the back, which add up to 8. And so if I look at my dimensions, it's 2 by 2 by 2. Now, they took that square root symbol and put a little 3 up here so that we would know that we're looking at cube roots now. So the side length here is 2. So the cubed root of 8 is 2. Okay? So it takes you up to a little bit different thing. We have to think cubes. So I want you to take a moment to think about this pile of cubes and imagine there's no missing holes in here. How many cubes would this be? So just in your head, think about it, and then raise your hand when you think you've got it. It's going to be an exciting video. What do you think it is?
Is it 27?
It is 27. So there's 27 total cubes here. So let's just write that on the side here. There's 27. And then the side lengths, it's 3 wide, 3 long, and 3 high. So you could say that 3 cubed is 27, and that leads us to the fact that the cubed root, so you have to make like a check mark with a line and this little 3 in here. So the cubed root of 27 is 3. And this is the side length for a cube. Okay? And then there's only really one special one that you can draw a picture for. This one is 1 by 1 by 1. So 1 times 1 times 1 is just 1. 1 cubed is 1. And the cubed root of 1 is 1. This is an intro. I don't expect you to have this down right here. I'm going to go into more detail on the other page. But I like looking at the visuals. Why do we call it a cube? It's because you could make a cube out of it. Why do we call it a square? Because you can make a square out of it. No one showed this to me when I was in school. We didn't have the pictures. They just showed us a little check mark thing and we had to figure it out. I think seeing the visuals makes it a little bit more real, and why do we call it what we call it? Okay. So, I've got to remember what I did with my notes. We're going to go over to the other page and talk about roots in a little bit more depth and give you guys some more information. There we go. Oh, not what I wanted. Okay. So this little number up here, you could put a number in the box. I'm going to put 3 there just for an example, and 8 here because that's the one that we just saw. There's a little line here where we're supposed to write this. It really isn't useful because it's too small. This number right here is called the index. So basically this is telling us if we're looking at a square or a cube, you can actually have this be a 4, 5, 6. It can be any number. Okay? This number that's inside, the 8, is called the radicand. These are not things that it's super important. I mean, it's vocabulary. I don't want to say it's not important, but these are not words that like we have to like totally quiz you on over and over. It could be knowledgeable questions though. What is the number on the inside of a root? It's called the radicand. This is called the index. And then this symbol is called the radical symbol, and the whole thing is called a radical. And that terminology, knowing that this symbol is a radical, and that it stands for a root, that would be the most important vocabulary to remember. In high school, I use the term radical and root all the time. And so that would be some important things. So there's just some different pieces here. This index basically tells you this is going to be the opposite or the inverse operation for a power. Okay, so over here to the side under the index, we're going to put it's the inverse of a power. Or you could write opposite if that makes more sense to you. I want it to make sense in your notes. So this is telling me what to the third power makes 8. And we're going to go through that a little bit. Now you might have noticed when we did the square roots a little bit ago that there was no number here. Square roots are used so much that they decided just to drop the number. So down here it says if the index is not written, it's automatically a 2. Square roots are just used a lot. We're going to use them to do some geometry stuff actually this year. So and some algebra stuff. It gets exciting, learning some new things. And so if you don't see a number right here, it's automatically a 2. You're automatically thinking about squares. Okay, so let's go down through this. So I sort of broke this into sections. I want to look at square roots first. This is your square root symbol. When you're drawing it, it's just a check mark with a line. It's basically what it looks like. And so we're going to look at just some, I want to think of them as just sort of fact families. Kind of like you've done in the past with your multiplication and division tables or your addition and subtraction tables. It says if 5 squared equals 25, then when we turn it around, the square root of 25 is 5. So if I made a square that had 25 little squares in it, the side length would be 5. But we're really just looking at what times itself makes 25. So let's do another one. If 7 squared equals 49, then somebody help me fill in the second part. I'll help you out. The square root of, which number goes in here? Johnny?
49.
The 49. And what does it equal?
7.
7. So we're just kind of going backwards from powers. This is the opposite operation of a power. You've been doing powers for a couple of years. Now they're telling you what's the opposite of a power. How do you go backwards? Okay, so now we're going to switch this around. If the square root of 81 is 9, then that means that 9 squared is 81. It's just 9 times 9. So somebody help me do, I'll stop for a second. I know you guys are writing. I just get excited. Like I have it written down. So we'll do the next one. The square root of 121 is 11. Then what math fact goes with that? TJ.
11 squared equals
11 squared is 121. So I just want you to have this really firm idea that they are opposites. They're inverse operations. Now, what you're really going to have to be able to do this year is tell me what the square root of numbers are. And we're actually going to have some flashcards, but we're going to do it in Quizlet, where we learn some square roots. And there's games and stuff in there, so we can make it fun. So the square root of 25, we saw up here was 5. So a lot of your problems, you're just going to have to tell me what the square root is. If I want to know the square root of 100, what squared is 100? Brian?
10.
10. Good job. So it's because 10 squared is 100. Now 144 is a little bit bigger. You have to know your multiplication facts a little far. What times itself is 144? Jaden? 12. Rhett. The square root of 4. What times itself is 4? 2. Good job. Making sure everybody's awake. Okay, now here's a critical thinking question. And it's an important thing for 8th grade that we get this down, because in high school we start looking at some things that go with this. Note, you cannot take the square root of a negative number. Why? So let's just think about this. Let's say that I have the square root of negative 4. Why can't I do that? Think about it backwards. So I would have negative 4 squared I'm sorry, I would have something squared equals negative 4. Why doesn't that work?
Because the parentheses are there.
Okay, what does the parentheses do?
It cancels out.
Oh, so you mean if I have a negative and a negative? So I could think, oh, it's negative 2, but then if I do negative 2 times negative 2, they have the same sign. So that would actually give you positive 4. So I can't take a negative times a negative to get a negative. So it just doesn't work.
Oh.
So doesn't work. Now in high school, we find a way to work around it. But it's important for you to know there's no real number answer to the square root of negative 4. And so we're going to write out an explanation because that's something that's in our goals for this year based on all of our data from last year. So we're going to say no because it says you cannot take. So I guess it doesn't ask no. So why? It's because if you square any number, positive or negative, you get a positive answer. So you have to think about it backwards. You have to think about those inverse operations a little bit. If I square positive 2 and positive 2, I get a positive 4. If I square negative 2 and negative 2, I get a positive 4. And when you're writing out explanations, sometimes it's helpful to write out a little bit about, well, to illustrate this, here's an example. And you could kind of do what we did over here and show negative 2 times negative 2 is 4. And then if I did positive 2 times positive 2, I also get 4. It just doesn't work because it has to be the same number twice. Now, cube roots are a little bit different. I'm going to draw a line just because I started to get down into that area and that bothers me. Okay, so the cube root symbol has a little 3 there that lets me know I'm looking at cubes. And so it works kind of the same way, except we don't have as many of these memorized, and you're not expected to know as many. We're going to learn a few. So 4 to the third power is 64. The inverse, the other fact family number statement we can make is then the cubed root of 64 is 4. If I made a cube with 64 little blocks, each side would be 4, because 4 times 4 times 4 is 64. Okay? So let's see if you guys can help me do the next one. If 3 cubed is 27, then the cubed root of, Johnny? 27 equals 3. Awesome. And I think we actually did that one before, but I'm just trying to show you how you can go back and forth. And this is going to help us with the algebra piece we have to do with this year as well. Okay, on the next one, if the cubed root of 512 is 8, then I could say that 8 cubed is 512. That seems wrong. Okay, that's right. I don't know why that seems weird to me. All right, let's look at the next one. So if the cubed root of 1,000 is 10, then what would be the other number sentence I could put with that? So look at what we just did. Jaden, do you have it?
10 cubed equals 1,000.
10 cubed equals 1,000. So these are just showing you backwards and forwards. A cube and a cube root are opposites. It's kind of like plus and minus or multiply and divide. Okay, now here's a note. You can take the cubed root of a number. So let's look at the cubed root of negative 8. So the cubed root of 8, actually, did we do that one on the other page? So we had the cubed root of 8 was 2 a little bit ago, and that was because 2 cubed is 8. So if I have negative 8, what we need to look at is if I take negative 2 and cube it, is it going to come out negative? So we have to think about our negative positive multiplication rules. So if I have negative 2 times negative 2 times negative 2, what sign do I get out of that? It is a negative, because negative times negative makes it positive and another one makes it negative. It does come out negative 8. So if you have an odd power, it can come out negative. So the cubed root of negative 8 is negative 2 because negative 2 cubed is 8. So that's just giving us an example of why it works, and I kind of wrote out my work here to explain it.
No,
So, yes. So just we mostly in 8th grade are going to do square roots and cube roots. About sophomore year in high school, we really start looking at like 4th roots and 5th roots and 4th powers and 5th powers. And we get a little bit beyond what you can draw in a picture.